So what is industrial engineering? Well, we can start with a dictionary definition, which may use some terms you're not familiar with, so let's start with something a little more basic. Statistics are quite familiar to everybody and are used frequently in industrial engineering. For example, if you were in charge of a theme park, some of the statistics that you might be concerned with are admittance rate, to see who's coming into your facility, how often, and in what intervals. Ride popularity may also be important to you. For example, if you were comparing a roller coaster and a carousel, you may find out that the roller coaster is more popular than the carousel, and therefore you should build more roller coasters in the future. Wait time is something we can all relate to, because nobody likes to stay in line. By plotting two statistics on an XY chart, you may learn new things about your process. For example, if you compare the time somebody spends in line with the probability of them leaving that line, you may find that there is linear correlation between the two variables. That means the longer somebody spends in line, the more likely they are to leave that line. You may also find that there is no correlation, which implies there's no relationship between the two variables. Using this information, you can make good business decisions between option A and option B. You may also find that one of those options results in more money for your business, and one of them probably shouldn't be done. Quality is another aspect of industrial engineering that applies to all types of businesses. For example, with a theme park, your quality of service may include wait times. So if you are waiting in line for an attraction, your opinion of the service might be affected by the length of the line. But what if the line were longer? How about a lot longer? Would you be willing to wait 20 minutes? How about 30 minutes? Would you be willing to wait an hour? These types of problems are addressed with quality engineering. But how would you approach this problem? By arranging data about your process on a frequency chart, you may find that it follows a normal distribution. That means this point right here is the most frequent and is the center of your process. Represented by mu, it's equal to the mean of all your data points, and for our case, it could be equal to 20 minutes, 30 minutes, or 60 minutes. So how would you improve this number? Work measurement is a tool you can use to improve the quality of your service. So if you had a stopwatch and you wanted to improve wait time, you might take it to the loading area for the ride, and you might time when the ride comes in, people get off, and then new people arrive and the ride leaves. This is known as a time study. But it may also help to look at some of your workers as well. Their safety and well-being are also important, so if they have to stand for long periods of time, is there any added stress on their feet? If they have to pull a lever, do they strain their back? Can they see clearly and make sure the work area is free of hazards, and if they work near heavy machinery, is their hearing alright? Fitting the worker to the work area is known as the field of ergonomics. You may also want to look at how many workers you have at any given moment, because that could be the cause of some of the delay. Doing this is known as scheduling. But now back to our riders. They just got off the ride, and they're looking to get some food. But they might not know the fastest way. There's a field of industrial engineering known as operations research that may answer this question. The first step is to map out your starting point and your destination on a map. And from there you can add constraints like one-way streets, or perhaps bad turns. After that, you can transform it into a network node diagram. And with it, you can use linear programming to come up with an optimal solution. And this solution could be shortest distance, shortest time traveled, or any other objective that you set. But customers shouldn't be expected to know linear programming to find the food stand when they leave a ride. But thankfully these kind of shops are located at the end of rides, so customers exiting will see the shops, get excited, and decide to buy something. But what about the alternative? What if the food shop was at the beginning of the ride? Would you want to eat then? Probably not, because then the ride wouldn't be very fun. These kind of problems are what's considered in facilities planning. All of the topics covered here and many more are all part of industrial engineering. If any of this interests you, consider joining the Institute of Industrial Engineers or pursuing a degree in industrial engineering.